Hey folks, I'm Mr. Hartzler, and I want to talk to you about operations on functions. Let's get started with some of the equations for that. So addition, it's kind of what you would expect, right? You're adding two things up. But if I just add them inside the parentheses, that's the same as just adding them separately. So don't let that part freak you out. Same thing with the multiplication. It's just like multiplying f with g, and dividing, same thing. Put f on top and put g on bottom. No big deal. Don't let any of that bother you. Just do the thing you'd expect yourself to do. Let's go through some examples though. So here, they told me f of x equals 2x, g of x is 3x plus 5. And then it says to do the indicated operation. This one, just saying to subtract them, f minus g. So I take my first thing, 2x, and I subtract all of g. The part people are going to mess up here is that they're not going to put that second chunk in parentheses. You have to put each of those pieces into parentheses, right? Because this whole thing is f of x, and then I'm subtracting all of g of x. That whole thing gets subtracted, so all of that has to be wrapped up in parentheses and subtracted away. I need to distribute that minus sign in. So then it's 2x minus 3x minus 5 now because I distributed that negative. Then I combine like terms. So I have 2x and 3x. Gets me a negative x minus 5. Done. Next one, I'm adding two things up. F of x plus g of x. F of x is the 2x. No big deal there. Adding that to g of x, 3x plus 5. Now this one's kind of nice. Because it's addition, the parentheses don't become as important here. Right? There's nothing to distribute in. I don't have to worry about it. So 2x plus 3x gets me 5 x's, and then I have to add 5 to that. Nothing special. I just leave it like that too. Neither of those things are like terms. I can't combine them. Can't combine stuff with x and stuff without x. I just have to leave it there. My next one, a little bit more challenging, right? Division, and we also have to state any restrictions on the domain. Let's plug stuff in first, then we'll talk about the domain. F of x over g of x with f over g with an x plugged in. That's what that really means. So it's going to be f of x on top of a g of x. And I know what f of x is. They told me in the problem. It's this thing right here. So I have 3x divided by whatever g of x is. Well, they told me that it's 2x minus 4. Now there's usually, almost always, I can't do anything else to it. That's it. Gotta leave it. But this restrictions has to come into play. My restrictions are that I can never divide by 0, and I can't take the square root of 0. So, I can't take the square root of a negative number, but I can't divide by 0. So I have to take this bottom, 2x minus 4, and that's never allowed to equal 0. Right? I can't take a cookie and divide it up into nothing, because then the cookie just has to disintegrate. So I then have to solve for x. I'm going to add 4. And now I have 2x cannot equal 4, so I have to divide by 2. And now I know that x cannot be 2. 4 divided by 2 gets me that 2. X cannot be 2. That is the restriction on my domain. Domain is inputs. I can't plug in a 2. Doesn't work. Then I'm looking over here. F times g, because there's nothing written in the middle. So that's f of x times g of x. Substituting in the things I know that f of x is 3x, and I know g of x is 2x minus 4. So multiplication and subtraction are going to get distributed. So this 3x, I have to distribute it to both of those terms. 3x times 2x, what's x squared? Not just 6x's. It is now 6. Oh, that's a terrible 6. 6x squared. 3x times negative 4 gets me negative 12x's. And multiplying like this is not going to give me any restrictions on my domain. The only time I'm going to get restrictions is when I'm dividing stuff or if I have a square root. Those are the only two times. All right, let's keep going. More definitions. I know, it seems like a lot. This is composition of functions. Do we get a whole new symbol here? It is... Where's my cursor at? This little dot right here. My pen doesn't quite show up the way I want it to, but you get it. That open dot there. This is called composition. So it's like composed of, or like what something is made up of. So if I read this from left to right, it says it in the middle there too, the say it stuff. This is f composed of g of x. So that's actually I would read the right side of this. f composed of g of x, or f of g of x, depending on how you want to read that. So the line down below that, it's g of f of x, or g composed of f of x. Really, all this means is substitute what x is into g, then plug all of that into f. The important part here is I work from right to left. I take x and plug it into g. I take all of that and plug it into f. Let's get started with some examples. I'm here. Given these functions, I have f, I have g, okay? I like to write them like this here because I think this is the harder one. I think it's easier to see it like this. So this is f and then g of x. So I already know what g of x is. It's right here. So instead of g of x in the parentheses, I'm going to write what that thing is, x squared plus 1. So now all of this is an input. All of that gets plugged in to my f function. My f function says 4 times x plus 9. Well, 4 times my input plus 9. I like to swap out x with literally the word input. 4 times an input plus 9. What am I plugging in? All of this. 4 times my input, that whole thing, plus 9. Now I have to distribute because I have multiplication happening. Multiplication and subtraction, I often have to distribute stuff. So that 4 gets multiplied through. What's 4 times x squared? 4x squared. What's 4 times 1? 4. And then this 9 is just being added off to the end, so I'm just going to add it off to the end. Then I have like terms, so I'm going to add those suckers up together, and I get 4 plus 9 is 13. No restrictions to my domain because, you guessed it, no square roots and no fractions. So I don't have to worry about any kind of domain restriction. So now g composed of f of x. Take an x, plug it into my f function. Done. They gave it to me like that. Then I plug all of that into g. G gets the whole f of x plugged into it. So the g function gets all of f of x. What is f of x? That's 4x plus 9. I'm plugging all of that into g now. And what's g say to do? My thing squared plus 1. What's my thing? 4x plus 9. So that's my thing. It gets squared, and I'm going to add 1 to it. Now this part's tricky. A lot of people are going to say 16x squared plus 81. I have to FOIL this out. If there's a plus sign in the middle, I've got to FOIL it. So that's 4x plus 9 times 4x plus 9. Then I have to add a 1 to it. So foiling, first, outer, inner, last. Take my first thing and distribute it to this 4x. I get 16x squared. Outer term, so this 4x times the 9. That gets me 36x. Inner is 9 times 4x. Ooh, another 36x. Nice. And then I take that 9 and I distribute it to that 9. And that's where the 81 comes from. And I still have to add that 1. Nothing special. I'm just bringing it down. Now I can combine like terms. I have a 36x, and an 81 and a 1 are both like terms. So I have 16x squared plus 36x plus 36x is 72x's. 81 plus 1 is 82. I know, the numbers get a little bit big, but use your calculator. It's not too shabby. All right, let's keep going with more examples. Now with numbers. This applies to everything, okay? These are the harder ones, but even the multiplication, they're not terrible. This is an f with a g of 1 plugged in. Right? I like writing it like this. It's a prettier format. So let's plug the 1 into g. And that's not what they gave me. Okay? So I need to find g of 1. That means I'm plugging a 1 into g. What's g say to do? G says to take my thing, square it, and add 1. What's my thing? 1 is my thing. I square it, and I add 1 to it. And what is 1 squared? 1 plus 1, 2. So I have 2 is equal to my g of 1. Now all of that, right, this 2 now gets substituted up here. So now I have an f that I have to put a 2 in. So I start on the far right side. That video might be left. Start on the far right side, wherever that's at on the screen. plug that into G. Once I simplify that, I plug all of that into F. Okay, so I keep working from my right towards my left. Plugged my 1 into G, found that answer. Took that answer, plugged that into F. What's F say to do? 4 times my number plus 9. 4 times my number plus 9. What's my number? 2. And then 4 times 2 plus 9. 8 plus 9 is 17. Off to the right, let's do this one. That's a G. But inside of it, I'm plugging in the F function. And inside the F function, I'm plugging in a 2. So I take my 2 and I plug it into the F. F of 2. And how do I find that? I plug 2 into my F function. They didn't give me that one exactly. I have to plug it in here. So I have 4 times 2 plus 9. 4 times 2 is 8 plus 9. Okay, so that is 17. Now I'm going to take all of that and I'm going to plug it in to G. So my G function now gets a 17 plugged in, right? Because that was F of 2. That's all of this. I'm swapping a 17 into all of that stuff. My G function says to take that 17, square it, then add 1. Ooh, what is 17 squared? 17, I'm going to do over here. 17 and 17. 9, 4, 7, 11. 7 and 1. So what's that? 289? Seems big, but okay. 289 plus 1. All right. 290. Kind of a big number, but it's all right. You guys have calculators. Oh, that's it, folks. That's all I need to tell you for this lesson. Enjoy it, and of course, let me know if you have any questions. Have a great day, everybody.